right now, we would like to give another introduction, understanding this is called, the North Star. If you turn it strong at night, this is the half of the heaven that you see. This is north, this is south, west, and east. Now, the rule is the North Star, that's a star it doesn't move. It's a star that it's stationary, because this is like the axis of the whole celestial sphere turns on that. It's 32 degrees above the horizon, the northern horizon. In New York, it's 40 degrees. This is the rule. To understand this better, again, I urge you to get a celestial globe or watch a lot of, make a search celestial sphere and try to educate yourself on this. This is the fact. You see, it says your latitude. Wherever your latitude is, that 32 that's where you find the North Pole, celestial North Pole. This point is called the zenith. It's called horizon, means it's a point above your head. You lay flat on the ground, straight above your head, you have a point. It's called zenith. Now, this is a very, very important circle, a great circle that's called celestial equator. Celestial equator is exactly 90 degrees from the pole. Obviously, here's the North Celestial Pole. So, 90 degrees from here, you have this imaginary line called celestial equator. It goes all the way from west to east. It touches the horizon at exactly west and at east. It's an imaginary line, but it's a very important line. An important circle, great circle. And let's see if you can figure out what's the tilt of this. How much degrees is this above the horizon, of the southern horizon? So let's do some math here. We know this is 32, 90. So this must be the remainder. It must be 180, everything together. So if this is 32, this is 58. 32 plus 58 is also 90. So it's always going to be the 90 minus the latitude above the southern horizon. So in New York, since we live on 40, so this will be 50. That's the rule. It's always 90 minus the latitude. That's the angle of the inclination of celestial equator towards the southern horizon. Now, so we have already two great circles here. Soon we'll have a third one, and that will form the famous spherical triangle. So again, we have the horizon. That's this circle here. The next circle is the celestial equator. And guess what? The third circle is the ecliptic. Now in this picture, we do not have ecliptic because we don't want to confuse you. But try to imagine, and this is why I urge you to get the celestial globe, that there is also attached to this whole celestial globe, there is also a line, that circle actually, that represents the ecliptic. And obviously it touches the celestial equator at 2 points, at Tele and Miznaim. That you know from the previous video that the celestial equator and the ecliptic, they meet at Tele and at Miznaim. And now try to imagine, I'll show you soon something that I have here, I hope you're able to understand, that this celestial equator, this is important to understand, has, I should have said this before I mentioned about ecliptic, so try to, I'll go back soon again. Celestial equator, imagine that this circle has numbers, degrees on it. 0, 30, 40, 50, 60, 180, all the way to 360. Okay. Again, try to imagine that in heaven you have these numbers. So the rule is, and actually there is the point where the equator meets with the Tele, that's where we decide to call 0. And then we continue going like this all the way. When it meets with Miznaim, we call that point 180. So there is, for convention, we divide the celestial equator into 360 degrees. Now, another important thing to understand is that the celestial equator keeps on turning. This line, it keeps on turning, and it keeps on, some points are above the horizon, some points are below the horizon. It goes every 24 hours, it makes a full circle. So this is the definition of the celestial equator, because this pole, you imagine somebody spins it, and when this gets spinned, this circle also gets spinned. So we have here west. This is Ma'ariv. Keeps on setting. Let's say the point here is 0. 0 sets, 10 sets. Keeps on setting. Setting the points. Each degree takes exactly 4 minutes to set. We're not talking about sunset. We're talking about the celestial equator. Forget about the sun now. There's no sun. We just have a heaven with a celestial equator. Every 4 minutes, another degree sets. So that means that 15 degrees to set takes 1 hour. 15 times 4. Each degree takes 4 minutes. 360 degrees takes exactly 24 hours. This doesn't matter. This rule applies every single place on the earth. That again, you have a certain point. Let's say right now the point 70 is on the horizon, the western horizon. 70. When will 71 be? 4 minutes later. Each degree takes say the same thing about rising, but usually we talk about setting. Doesn't matter. So this is a rule. The celestial equator equally, the degrees of it set equally in every location of the world. 4 minutes per degree. Let me, okay, before I'm going to show you the model that I have here prepared, let's see if I have a good picture here. Okay, this picture makes you a little bit more complicated, and I hope it's not going to get you too complicated. We have here the horizon, the celestial equator, and the ecliptic attached to it. The ecliptic is the Galgalan Mazalus. So here basically we have 3 circles. We have the horizon circle, the celestial equator circle, and the ecliptic circle. Now, try to focus where I'm pointing here with my cursor. You see here a tiny spherical triangle. You see the horizon, celestial equator, and the ecliptic. It's very important, very important, and I'll give you a hint why it's important. Because here what a huge question arises. If we have X amount of degrees of the celestial equator setting, let's say it's set now from 0 to 30. How many degrees of the ecliptic set in that same time? So basically from 0 to 30 takes 2 hours, right? So let's say we have 0 on the horizon. We wait 2 hours. And now we have 30 on the horizon, right? However, how many degrees of the ecliptic had set during this period, during these 2 hours? Very, very important question. It's a different circle. It's tilted. Has a 23. This we know some information. This is 23 degrees. You know this is 30. And we need to know 3 angles to solve this. The third thing we have to know is what's the angle of the horizon towards the celestial equator. This is this angle here, but I can't jump so fast. So this is once we solve this triangle, we know very, very important information that will lead us through the Rambam to figure out this spherical triangle. Again, the spherical triangle that contains part of 3 great circles of the horizon, of the ecliptic, and of the celestial equator. Now, I'm just going to show you another picture here. We'll scroll down a little bit here. This is a spherical triangle. Imagine this is the horizon. AC will represent the part of the ecliptic, and AB is the celestial equator. And we have formulas, and again we have to know this angle. This angle is the angle of the horizon towards we have to know the angle of the horizon. What's the horizon of the celestial equator? We can figure that out. We have to know the ecliptic of the celestial equator. That's this angle is 23.5 degrees. We have to know how you're telling me 30 degrees. That's AC is 30. And once we know this information, we can figure it out through formulas. I'm not going to go into that now. The sketch for Tlet totally set. Okay. Sketch for, okay, let me pass this sketch from Isnaim. Different setup. Okay, take a look at this beautiful picture. I think this is the best picture I ever made. This shows, this is the horizon, this is the celestial, this is the ecliptic. One more, different setup. Depends what time of the year. horizon